All right, here we go. Monday. Hopefully, you guys had a good weekend. Hey, one quick note: when you do the Google Forms, the actual first question after your name is just want to take a quick poll of whether you want to do a live class or not. Live class would be literally live. We would do it at our normal meeting time for period two. We'll do it on Zoom and we'll just do the class. I mean, it's going to be the same thing. It'll be these slides. The difference is that we'll do it live. You'll have a chance to ask questions or not. I don't want to pressure everybody into saying you got to do this. Not just go ahead and vote the way you want to vote. If you want to do it live, we can do it live. I don't want to do it live every single class, just simply because I know that there's eventually going to be some technical difficulties for either myself or maybe for you. You know, internets go down, Wi-Fi's have to be reset, that sort of thing. But I also don't want to say let's not ever try this. So my basic idea is that we'll do it like once a week type thing. That way we get to see each and all of us get to stay together as a class. Get to do some conversations between us two, and then obviously you can ask the questions during the class. If it's not something we want to do, that's fine as well too. Like I said, we'll just basically do like if 75% of you guys want to do this. If you answer yes to it, we'll do it. If not, then we'll just continue rolling the way we are. Not a single one of you has ever asked me a question, so that either tells me that you're getting this as I'm delivering it, or you're being lazy and you're not asking questions. So, like I said, there shouldn't be any questions on your homework that you don't already know the answers to, or at least think you know the answers to. The normal class, when you come to class, you're like, hey, how do you get number 13? Well, we got 2 days to get these things done now, so you should be sending me an email and saying, I don't get number 13, give me a hint or walk me through it. I'd be more than happy. I got plenty of time to give you guys assistance, so make use of that. Okay, enough of that. Let's go over homework, which was 11.4, 1 through 17 all. Believe it or not, we're going to use this homework today's class a lot. So here we go. Questions number 1 had 2 answers. So A was 8 and the area was 256. And once again, they're being lazy and not putting units. So A would be the apothem, it would be units, and A area would be 256 square units. All right, number 2, the radius is 5 root 2 and the area is 100. Number 3, the radius is 7 root 2 over 2. That's 7 root 2 over 2. And the apothem was 7 halves, or 7 over 2. Number 4, the radius is 2 root 3 and the area is 24. Number 5, the area is 3. The perimeter is 18 root 3. And the area is 27 root 3. 27 root 3. All right, number 6, the radius is 8. The perimeter is 24 root 3. And the area is 48 root 3. Number 7, the radius is 4 root 3 over 3. The apothem is 2 root 3 over 3. And the area is 4 root 3. Number 8, the radius is 3. The apothem is 3 halves. And the area is 27 root 3 over 4. Number 9, the area is 2 root 3. The apothem is 2 root 3. The perimeter is 24, and the area is 24 root 3. Number 10, the radius is 10. The perimeter is 60, and the area is 150 root 3. 150 root 3. Number 11, the radius is 4 root 3. The perimeter is 24 root 3, and the area is 72 root 3. And number 12, the radius is 2 root 3. The apothem is 3, and the area is 18 root 3. All right, that was a lot of work. Believe it or not, you're going to use all of that today. All right, just find the area of each polygon. Okay, number 13, it's 36 root 3. Number 14 is 128k squared. Number 15 is 216 root 3. Number 16 is 32 root 3. And the last one, number 17, there is, it's 4 parts. I'm sorry, 5 parts. There's A, B, C, D, and E. All right, here we go. So let's see. Why is the measure of AOX 18? Well, it is a decagon, so it's got 10 sides. So around 360 divided by 10 will be 36, And so it's asking what would half of that be, so the half of 36 is 18. All right, number B, asking you to do a, boy, this is a lot. There's 2 questions here, aren't there? Part B, the first part, the sine would be 0.309, and the cosine would be 0.951. 951. All right, C, the perimeter, 6.18. D, the area is 0.29. And E, the last one, the area of the whole thing would be 2.94. 2.94. There you go. Hopefully you got a good use of your calculator there. All right, go ahead and answer the next question on the Google Forms. How many you got wrong? And yes, I am reading your comments. I forget who it is that put a funny answer the other day. I missed one or something like that, and then they said, no, I'm lying. I missed 27 or something like that. Okay. So a calendar, it's going to be 3 straight weeks of this. I believe, I'm not 100% sure, but that following Monday is Parent-Teacher Conference. We haven't decided how we're going to do that. Typically, our second Parent-Teacher Conferences is devoted only to students who are in danger of failing. There's nobody in this class that's the case, so if everything stays the same, I don't anticipate, at least for you guys, do a parent-teacher conference for geometry. We will open it up to any parent that wants to have a conference, though. And that would be that following Monday. So this is 3 weeks, and I forget what it is. It's the end of April. So I'm not sure whether we'll have classes. I assume that we'll still have classes since this is done on a video. Okay, here's your homework tonight. Okay. All right, today we're going to areas, and I've told you all along there were just a few things in geometry that we can't prove. And by prove, I mean like literally do a proof on it, and today is one of them. So we're going to do something that's kind of sort of like a proof. It just basically shows you some evidence and asks you to extend that evidence further and come up with a conclusion. That's not a proof. That's using evidence to come to a conclusion. You know, in the real world, you know, when a detective finds a bunch of clues and they make a conclusion, that's not proof, right? That is putting all the facts together and coming to a conclusion. Well, that's not how geometry and proofs work, but there are a couple things in geometry that we cannot prove given our level of mathematical knowledge, and unfortunately, circles kind of brings that in. So I am not going to give you a proof of circumference or area, but I'm going to show you some evidence that suggests what the answer should be. Until you get to calculus, you don't actually get a formal proof for circumference or area. It turns out the circles are really complicated. All right. So the big goal here is to calculate the circumference in the area of a circle. And this is something you've been doing since at least 6th, maybe even 5th grade, just using 2 formulas. Now remember, those formulas have always been presented to you like, hey, trust us, this is real, but no one's ever actually proven it to you. And no, I can't prove it to you today, but I can certainly point to some evidence that strongly suggests why these are the formulas. All right, so the big picture, circles. We have 2 measurements that we take for circles, but the perimeter and the area. And remember, we call the perimeter of a circle the circumference, so it gets a special name. And we've known for a while, like I said, I don't know when you first learned this, but generally it's around 5th or 6th grade, that the perimeter of a circle, or the circumference, C for circumference, is pi times its diameter. Many math books also give you the formula C is equal to 2 pi r. I don't particularly like that particular formula because it's easily confused with the area formula. So most of the time I say pi d. The area one's pi r squared, and you can see why you can confuse the circumference and the area because they both have a 2, they both have an r. This is why when I teach this for, not in geometry obviously, but for my lower level math classes, I always teach them pi d. Because you know, if you know what the diameter is, you can convert that to the radius or vice versa. Okay, so today we're going to we're going to attempt to show you evidence that suggests why those are the formulas. So this isn't a real proof. So here we go. This is going to be going to do a table And we're going to consider a polygon of many different sides. We'll start off with a simple one. We'll start off with a polygon of 4, and it's regular polygons of 4 sides. So our goal here is to complete this table. So you are going to need to complete this table. I'm going to show you, I think I do like 3 of these, and then you're going to have to finish the table. Now this certainly might take you a solid 10 to 15 minutes to complete the table, but I do need you to do the process so you understand it. All right, so the first thing we're going to do is we're going to consider a circle that circumscribes a square. In other words, a regular polygon of 4 sides. All right, so we see where the radius is. So the first thing we're going to do is we're going to calculate the perimeter. We'll do perimeter first, and then we'll do areas. Okay, so let's think about the perimeter. The perimeter of this, right? Well, it'd be kind of hard to do, but one thing we could do is we could make a triangle. You see the triangle I just made? So I'm gonna enlarge that triangle below. So it's the same triangle. I just need it larger so I can write things on it. All right. So well, R would be right there. That would be the radius. What would be the bottom leg of that right triangle there? What would be the bottom leg? Well, the entire side of the yellow square there would be S, on the side of it, right? The length of S. So therefore, of the blue triangle, that particular leg would be 1/2 of S. Does that make sense? The entire of the yellow part, the entire side of that would be S. So for my triangle, since I've only got half of it, then obviously its length would be 1/2 S. And then the long leg there would be the pothom. Okay, all that's should be familiar from yesterday's class or from the last class. All right, so let's see. I'm trying to calculate the perimeter. So in order to calculate, not the perimeter of the triangle, but the perimeter of the square, the yellow part. So in order to calculate the perimeter of the yellow polygon, I would need 4 sides, right? And one side is equal to S. So if I could somehow tease out what S is equal to, then I can multiply 4 times S and I would be there. And that's kind of what the technique we're going to use. Okay, notice there are no numbers on this polygon at all, either for the triangle or for the square. All we have are relationships, and we have variables, R, A, and S. Okay, so how are we going to do this? Well, we're going to go to our old friend trig. Remember, we could use Pythagorean theorem if we had 2 of the sides, and we don't. We have none of the sides. So let's see if we can figure out trig. So I want you to think about the central angle there, the central angle. Now, I didn't draw the full isosceles triangle there to the other consecutive vertices of the yellow polygon. But if I did, right, you'd have 4 interior angles, and those 4, well, there's 360 degrees in a circle. 360 divided by 4 would be 90. So the central angle would be 90. And therefore, since we have a triangle there, it would be 1/2 of that 90. Therefore, that angle right there is 45. Now, I don't want to say that again. If you need to rewind the video, please do, to hear what that basic. But the basic idea is we know there's 360 degrees in a circle. The central angle there, that would be the full isosceles triangle, not just the right triangle right there. So if I went from one corner to the other corner of the yellow polygon, that would give me 90 degrees. And then 1/2 of 90 is 45. This is the technique you're going to do for this entire table. Okay, and like I said, I'm going to show you 3 examples here. All right, so my claim is I can have trig. What are we trying to find? We're trying to find S. So I need a trig function that somehow uses S. So we got sine, cosine, tangent. So let's see, cosine uses the adjacent and the hypotenuse. No S there. The tangent uses the opposite and the adjacent. Okay, I might be able to use that. And lastly, the sine uses the opposite and the hypotenuse. So I could use that as well, too. So I could either use tangent or I could use sine. I'm going to use sine. So let's see. Sine of 45, because would be opposite. The opposite is 1/2 S over the hypotenuse, which is R. See what I did there? And then I just simply solve for S. All right, so let's see. Solve for S. Let's multiply both sides by R. Okay, and then to get rid of that 1/2, let's multiply both sides by 2. All right, if you need to pause the video and think about the logic of how I got that, but basically I just solved for S. And why am I solving for S? Because I'm trying to figure out the perimeter of the yellow polygon, the square there. Okay, so now I know what 1S is, right? 1S is equal to 2 sine 45 over R, or 2 sine 45 times R. Okay, I agree it's not a very pleasant answer there, but at least I solved for one side. Now, how would I find the perimeter? I would just multiply that by 4 because there's 4 sides. So one side is 2 sine 45 R, so 4 of them will be 4 times that. In other words, 8 sine 45 R. That will be what the perimeter of the yellow polygon is. All right, so let's see. What can I do with that? Well, I can certainly take my calculator, make sure it's in degrees, and do 8 times sine 45, and I get to that number right there. I'm going to round each one to the nearest hundredth. Okay, so I get 5.66 R. Well, that's my answer. And you're like, I have no idea why you did that. Well, you will by the end. Okay, so like I said, we're going to do this 3 times. We're just going to increase the number of sides of our polygon and see what we get for its perimeter. Okay, so the first one we did 4 sides at 5.66 times the radius. Well, let's see what happened if we did Polygon of 6 sides. Remember, this is going to be a hexagon inscribed in a circle, okay? Or a circle circumscribes the hexagon. So if it has 6 sides, remember this from doing from last night? If it has 6 sides, right, the triangle, well, let's see, 360 divided by 6 is 60. So half of that, in other words, the top angle there would be 30 degrees. And then the rest is still the same. Now I'm going to leave off the A for the apothem because I'm going to use the sine each time. I could use tangent, but I'm going to use sine. Okay, so let's see. Using some trig, the sine of 30 would be the opposite over the hypotenuse. And then I'm going to do the same thing I did before. Multiply both sides by r, multiply both sides by 2, and then take my calculator and find out what 2 sine 30 is. Well, 2 sine 30, I'm sorry, before I do that, before I do 2 sine 30, I just figured out what 1s is. Now it's a hexagon, so there's 6 of these for the perimeter of the hexagon. So 6 times 2 is 12. Okay? Sorry for advance. I can't go back when I'm recording my voice. I can't go back a slide, so unfortunately. Okay, so we get 12 sine 30. Now I'm going to grab my calculator. 12 times sine 30 is equal to 6. Wow, we got a nice whole number there, and it's 6R. So we get 6R. And most of you should be saying, I still have no idea why you're doing any of this. You'll see. All right, let's do one more together. Let's do 8. So let's see. If it's got 8 sides, so it's an octagon inside a circle, 8 sides, 8 goes into 360. That would be 360, that would be 45 times, and half of 45 is 22.5. Makes sense? This is the process you're going to have to do for the rest of the table. Notice there's 1, 2, 3, 4 blanks there. You're going to be doing this 4 more times. So this is the process. You draw the triangle. The hypotenuse is always going to be r. The short leg is always going to be 1/2 s. The angle is going to be, you take the number of sides, divide it into 360, and then take half of that. That's where that got that 22.5. So I'm doing octagon. 360 divided by 8 is 45. Half of 45 is 22.5. And then I do the trig with sine. So, and I wrote 45. That should say 22.5. So let's see. The sine of 22.5 is equal to 1/2 s over r, opposite over hypotenuse. Multiply both sides by r. There, see, I wrote right number there. 22.5, and then multiply both sides by 2. That gives me 1 side. Now there's 8 sides to the octagon, so I multiply the whole thing times 8 to find the perimeter, and I get 16. Grab your calculator, do that math. 16 times sine 22.5, and we get 6.12 r. 6.12 r. Okay. So here's what I need you to do now. Pause the video or rewind. I need you to do it for a decagon, one with 20 sides, one with 30 sides, and one with 100. I gave you nice friendly numbers that all evenly divide into 360, okay? So do that first. You might have to rewind the video and see how I did, but the process is the same. The only difference is you're doing something with 10 sides, 20 sides, 30 sides, 100. And hopefully by the end, you will have noticed a pattern. So once you're at the end, right, before you go on and see what the answers are, I want you to answer the next question on the Google form, which basically says, so what does it look like is happening to that pattern there? I went 5.66, then I went to 6, then I go to 6.12. It looks like it's slowly approaching a number, and that's what the question is. What number does it look like it's approaching? Okay? All right, so go ahead and do that. All right, hopefully you weren't too confused. This is what I got for all my ones. So it went from 5.66, then it went to 6, and then it slowly creeps up, and it seems to get to 6.28. So the question is, well, it looks like it's approaching 6.28. If I did 1,000 sides, right, you would still get 6.28. And no matter if you did 1,000 or 10,000 or 1,000,000 sides, you'd still get 6.28. So what number is it approaching? It's approaching 6.28. It's just getting more and more closer and closer and closer to 6.28. If you did it 1,000,000,000 sides, it would still be 6.28. Kind of interesting. Okay. Well, don't panic if you're like, I have no idea why we did any of that. You'll see here once we get to the very end. When I will give it away as soon as we start doing the area column. So let's do the area column. All right, so the area column, let's see. We got to figure out the area of that polygon yellow. So it's a square. It's got 4 sides. So we know if we had one side to find the area, we would just square it, one of the S's. We could also use that other formula, right? Remember the other formula, one from yesterday, which said that for any regular polygon, that the area is equal to 1/2 the apothem times the perimeter. So I'm going to choose to use this formula instead. All right, so let's see. What do I need for this formula? I need the apothem, and I need the perimeter. Well, check it out. You just did a whole column of perimeter, so I already know what the perimeter is. I just need to figure out what the apothem is. Well, the apothem is exactly what we did before, right? The only difference is this time I'm going to label. So I'm just going to do the same math, right? You could use the same scratch work you did before. Hopefully you didn't throw it away. And then we're just going to solve this triangle for A instead of for S. So we got some options. We could use tangent. We could also use cosine. I'm going to choose to use cosine. So let's see. The cosine of 45 would equal to the adjacent over the hypotenuse. Okay? So I'll multiply both sides by r, and we get A is equal to cosine 45. Sorry. Well, so that is what the A is. So I go back to that initial form, the one there all the way to the left. And for A, I'm going to write cosine 45r. And for P, well, I'm going to go back to my table because I know what the perimeter is. The perimeter is 5.66r. So take a moment before you continue on and make sure you understand what I did there. Now, I did put approximation symbol because remember that perimeter, we had to do some rounding there. Okay, so let's see. A was cosine 45r, and then the P was 5.66r, and I got that from the table itself. All right, well, we can do some math there. Let's see, r times r is r squared. I can do the cosine of 45 times 5.66, all divided by 2 on my calculator, and I get to that. 2, I'm doing some rounding there to the nearest hundredth, 2r squared. So I got an area of 2r squared. And I'm going to continue this entire table. I'll do 3 of them with you, and then you'll do the rest by yourself. So let's do it for the hexagon. So for the hexagon, let's see, for the hexagon had the interior angle of 30 degrees, okay? So let's see, once again, we're going to do cosine. Cosine is the adjacent over the hypotenuse. Multiply both sides by r, that's what the apothem is. We plug that answer right there in blue and all the way to the formula on the left there for the letter A. And the letter P, well, we look at our table and P says it's 6r. Okay? R times r is r squared, and the cosine of 30 times 6, all divided by 2. Or you could just do 3 times cosine 30, that's 6 divided by 2. Well, that equals 2.6 r squared, so 2.6 r squared. Okay? Continuing on, for the octagon, remember the octagon had the interior angle of 22.5. Okay? So we do cosine of 22.5 is equal to the adjacent A over r, multiply both sides by r. Plug that into my apothem, or my area formula that has the apothem and the perimeter. The perimeter is 6.12. The apothem was cosine 22.5 r. R times r is r squared. Cosine 22.5 times 6.12, all divided by 2, is 2.83 r squared. So let's look at our answers. We went from 2 to 2.6 to 2.83. It looks like we're approaching some number. So what I want you to do is to complete the table and see what number you're approaching. See what number, and this is the one that's kind of will give it away. All right, so go ahead. And remember, why are we doing this? Because remember, the more sides we add, the closer the polygon is to a circle. So if we do I don't know, 3 trillion sides, it's going to be awfully close to the area of a circle. Okay? All right, so go ahead and pause the video and complete the table. Okay, so what number do we approach? And this is kind of what gives it away. Look, we got 3.14. That's pi. Therefore, the area of that polygon is pi r squared, right? And remember, that would be for a polygon of at least 100 sides, right? So if we do a quadrillion sides, we're going to be really, 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 really close to the actual answer to the area of a circle. So hopefully that is proof. Oh, well, see, well, that proved it for area. How about the other number, 6.28? Well, that's not pi. 6.28 is double pi. In other words, that's where the circumference is double pi. 2 times 3.14 is 6.28. Okay? You could also double the radius and call it pi d as well too. So that's where those two formulas. Now remember, that is not a proof, but it's certainly strong evidence for why those are the formulas. Whew, that was a lot of work. That was a lot of work. And oh, by the way, we haven't actually done any problems yet. All we've done is basically done a quasi proof, not a true proof, of why those formulas exist. So we need to write those down. This is not an actual theorem, right? They don't say this. I'm not sure why they don't do this. You know, this should be, I don't know, theorem 4 point blah blah blah. Or I'm sorry, theorem whatever chapter we're on, 11 point whatever. But they don't actually do that. So go ahead and write this down, please. It should be a theorem, though. You want to know why it isn't a theorem? Because we didn't really prove it. That's why it's not a theorem. Okay, it makes sense to me now. All right, so go ahead and write that down. Those are your two formulas. Some of you probably already have this memorized, though. Okay. So what's left to do is just a couple examples. A quick note, the Greek word for circumference is peripheria. Peripheria, and the first letter of peripheria is the letter P, lowercase p, and that is why they chose. Well, that's why they chose the symbol for pi is that. You know, why didn't they choose A for pi for area? You know, it kind of makes sense. But no, they chose the letter P to represent the word pi. Okay, so that's where that comes from. There's some Greek there. Notice that the letters there are pretty darn close to our letters as well too. They just have a different letter for different sounds. So that's the P sounding letter right there. You know, the E's make sense. The R's, now this is where it gets confusing. R's look like P's in Greek. The F sound is a circle with a slash through it. But the rest of the letter there kind of makes sense. So Greek's kind of an interesting language to learn. I know a little bit, but not much. All right, and also note this, that pi is an irrational number. That means it goes on forever, never stops. Therefore, to use it in a calculation, you actually have to do some rounding, right? You have two options, right? You can either leave pi as pi, that's called leaving the answer in terms of pi. So if you're calculating circumference and it says leave the answer in terms of pi, you get 2.4. You don't multiply 2.4 times pi, you just say 2.4 pi. Therefore, you can put an equal sign. But if you actually got to cut something, you know, or make something, or pour some liquid or whatever, you need to actually have a number that you can mess with. So what we do there is we do some rounding. We multiply by 3.14. You guys have been doing this for a while. All right, and then change pi to a rational number, 3.14. Because you've rounded. Nope, that's not new, of leaving things in terms of pi or rounding them using 3.14. The book also talks about using 22/7 for pi. I don't know anyone that ever uses 22/7. There's obviously, you know, because most of the math we do now is with calculators. So we either use the pi button. And by the way, the pi button on your calculator is an approximation. It's just a very good approximation. It goes many, many, many digits. But it is literally not pi. As we go up in higher in math, like next year Algebra 2 and onwards, very rarely are we going to use 3.14, the pi key. We're just going to leave pi as the symbol pi. All right, so here are the simplest problems. Go ahead and pause this, see if you can get these done before I do. All right, for those of you who need the help, let's see, or you want to check your answer. What's the area of a circle whose radius is 6 centimeters? Well, the area of a circle is pi r squared. So we plug in 6 for the radius, 6 squared is 36, multiply that 3.14, and you get that answer. This is literally a question that, you know, 5th and 6th graders are asked, so it's not too impressive for us being in high school. All right, circumference. What's the circumference of a circle whose radius is 6? It says leave the answer in terms of pi. Well, let's see, we know the formula is either pi d or 2 pi r. Since they gave us the radius, I'll use 2 pi r. So the radius is 6, so 6 times 2 is 12, so 12 pi. And notice I put the units there since they gave me units. Make sense? Okay, so those were the simple ones. Here's another simple one. This is the last question on the Google Forms. So go ahead and pause the video and answer this one for me. Okay, I don't know if you've ever been on an airplane, look down at Colorado, but when you go to farm country, this is what a lot of it looks like. You get these circles because almost all the crops that we grow in Colorado need to be irrigated. So we got this pivot arm thing that there's this metal pipe that squirts out water and it goes around in a circle. So it looks like what? A quarter of this circle is being stuff is being grown on it. The rest is just dirt. So it says what's the approximation of the area of the field that has been irrigated? In other words, the green part. Okay, so it's the quarter of the big circle. Well, the arm goes from the center to the out. Well, that would be the radius. So therefore, the radius would be 430. So pi r squared would be 430 squared times pi, and then divide the answer by 4. You get your final answer. Pretty simple thing with a calculator. No big deal, except plug in the numbers in their correct spots, and you get a very, very, very big number. Obviously, you're dealing with an agricultural setting, so that the numbers, especially if it was in meters, is going to be very, very large. Are we good on that? We'll do one, and this one isn't that. I will just say I teach this in pre-algebra as well too. I don't consider this a geometry one. This one is a bit more complicated. If you want to go ahead and pause it, I don't have this as a Google question or a Google form question, but if you want to pause it and see if you can get to the answer before I do, please do that. All right. So what does it say? It says, what's the circumference of a circle whose area is 25 pi? Well, I've got both circumference and area, so I need both formulas. So let's see, what does it give us? It gives me an area of 25 pi. So before I can use the circumference formula, I got to use the area formula. So it says the area, or A, is equal to 25 pi. And then I'm simply going to solve for r because that's what I got to plug in for my circumference. Circumference, all I need to know is what the radius is. So I can use the area formula to solve for r. Then I can plug that into the circumference formula. And I'm done. So let's see, what would I do to that algebraically? Well, one thing you can do is divide both sides by pi. If I don't divide both sides by pi, the pi's cancel. Now you can kind of see why you leave things in terms of pi, because you can do some good algebra with that. If we were to convert that to 3.14, you get these ugly, 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 messy numbers. But to do this by hand without a calculator, you can see that if we leave things in terms of pi, it makes your life a little bit easier. So take that, plug that into the r, and we get 10 pi. So there's your answer in terms of pi. And if we wanted to have an approximation, then we would just multiply by 3.14, move the decimal place once. So 31.4 units. Make sense? Okay. All right. Well, that was it for today. Don't forget that to make sure on Monday that you actually answer the question of whether you want to have a live class. And like I said, I truly don't want to do this every single day. It just gives us more flexibility if we're not tied to a specific time that we have to do this. So if technology breaks down, we're not in a world of hurt. So go ahead and vote the way you want to vote, and we'll just deal with it. Whatever you guys want. So yeah, that ends it, and I will see you guys on Wednesday.